everyone, my name is Ling. I'm glad to be here today. I am a software engineer at Google together with my coworker David here. David and I are on sister teams, and one of our team's shared mission is to help cloud customers collect telemetries. And we use OpenTelemetry to achieve this goal. That's why we are here today. So I'm gonna start this session with some introduction of the OpenTelemetry collector and a quick demo. Then I'm gonna hand it to David to dive a little bit deeper. David will talk about the collector's architecture and deployment model. So one of our recent efforts the team are working on is to add telemetry support for some common third-party applications. This slide here shows a list of these applications we recently added support for. It's not a full list, but it represents roughly what type of applications we were targeting at. Looking at them, you might think, wow, that's a lot of applications and potentially a lot of work to get there. Well, this is where OpenTelemetry came to our rescue and made our life a little bit easier. So OpenTelemetry supports many open protocols that a lot of these applications can speak. For example, on the metric side, it supports the modern OpenTelemetry protocol and Prometheus protocol. It also supports some of the older protocols like StatsD and OpenCensus. On the trace side, it supports Jaeger. That is a very common trace protocol as well. In addition to this, the collector itself is also more or less like a Swiss Army knife that can enable us to do many customization. We'll show a little bit more details in the next slide. So the collector has three components: receivers that determines what telemetry is collected in what kind of format. The processors determine additional transformation we might want to apply to the telemetry. And the exporter determines where the telemetry are sent to. To give you a closer view of what the typical receivers, processors, and exporters look like, we are gonna give you a quick demo. In this demo, we are going to showcase you how to use a collector. The collector will be installed as an agent inside the GCE VM. It scrapes metrics from a Kafka application, makes some modifications to the metrics, and then ingest the metrics to the Google Cloud Monitoring backend. So to get started, we need to first create a GCE VM. So here I have already created that GCE VM for you. After that, we need to install the Kafka application and also install the OpenTelemetry collector onto that VM. In order to focus more on the interesting parts, I'm gonna skip the setup steps. Now, as you can see, we already have a GCE VM called demo-kafka here. It has a Kafka running already, and we can quickly double check that. So here we go. It has Kafka 3.0.3.0 running. I have also installed the OpenTelemetry collector already on this VM. Note that because we need to send the metrics to Google Cloud Monitoring, the OpenTelemetry collector we use here is a custom build that also bundles some Google-specific processors and exporters. So before we start the OpenTelemetry collector, let's take a look at the configuration we have. So here you can see, let's take a look at the service section first. So the service section shows us roughly what the flow is like. Here we have only one pipeline called metrics Kafka. And it has three sections: receivers, processors, and exporters. As mentioned before, the receivers decide what telemetries are to be collected. The processors provide some flexibility here to filter these metrics and also transform them in certain ways we want, and eventually also help attach some additional information to the telemetry. Finally, the exporters decide where the metrics are sent to. So now let's dive into a little bit more deeper regarding the details of these components. So the first thing we're gonna see is the JMX Kafka receiver. So the Kafka receiver here is built on top of the JMX ecosystem. It basically asks for the Java jar path and the endpoint that the metrics are exposed at. And it also lets you specify how frequently you want the metrics to be scraped here. We set it up to be 1 minute. Basically every minute it will scrape the applications. Then for the target system, we want both the generic JVM metrics and also Kafka-specific metrics. When it's come to the processors, the first processor you will see here is a filter processor, because there might be many metrics available out there in the upstream collector. We might only want a subset of metrics that are for our users, which we believe are more stable or useful. So we have a filter here just to include what we want to be ingested. Next, we have a normalized sum filter processor. This one is to support normalization from some metrics where an appropriate start time might not be available. So this processor makes sure it will use the first data point as the start. This processor is required for compatibility with some of the Google Cloud Monitoring backend requirements. After that, we have a matrix transform processor. For the case here, we use it to modify the matrix names and add Google-specific prefix. Finally, the last one is a resource detection processor. This one helps us detect GCE-specific resource identifier, and it also attaches some metadata to the metrics. And in the end, the exporter part is pretty simple. It simply specifies that we want the metrics to be ingested into Google Cloud Monitoring. All right, now we have finished taking a look at the configurations. Let's actually start the collector. For production usage, we normally run the collector as a daemon, but for this demo, I stopped the daemon and I'm gonna start the collector manually. So it is a bit easier to see what the output is like. So it basically you pass in the configuration that we just looked at. And as you can see, it has now started the receiver, processor, and the exporters in the OpenTelemetry collector. It's running and processing data. And now let's go to the Kafka side and perform some actions there. So the first thing we're gonna do is basically, I'm gonna create a new window to create a Kafka topics. I have already done this many times before, so I'm gonna change this a little bit. Test topics, otherwise it's gonna complain, it already exists. Test topics. So this has successfully created that one. Let me modify my command here as well, because the next thing I'm gonna do is to set up something that will send Kafka message. So this is a quick while loop. It just, every second it sends a message to Kafka. So I'm gonna start this one. Yeah, looks like it's running. Now let's go to the Google Cloud Metrics UI and try to find the metrics we just ingested. So first we are gonna go to the GCE instance monitoring resource. As we scroll down, we'll see we ingested some Kafka metrics. We're gonna take a look at the message count because we just sent a bunch of messages to Kafka. Click apply. And as you can see here, after we start the for loop to send messages, the count of those messages started to increase. And that is the end of our demo. Thank you so much. I'm going to hand it over to David to talk about the collector's architecture and deployment model. Hey, David, do you want to take it from here?
Yeah, thanks, Ling. So far, we've heard about the collector's ability to glue together a lot of different sources for metrics, traces, and logs. And I'm going to cover how to turn that into a pipeline that you can run in your production environment to solve your own problems. So first, most of the complexity that we're going to be tackling today comes in getting telemetry from your application to the collector. So I'm going to focus on that and assume that the collector knows how to get telemetry into your backend. When thinking about constructing the pipeline, the first thing you want to think about is whether your application is pushing, like the OpenTelemetry format, to the collector, or whether the collector is discovering your application and pulling from it, because those pose different problems. In the case of push, the application needs to know where to send the telemetry. And in the case of pull, the collector needs to discover the application so it can scrape from it. Another thing you might want to keep in mind is that sometimes you want to do some calculations that involves taking a bunch of telemetry from different applications together and doing some math on it. So for example, if you have metrics and you want to drop a label, you need to make sure you collect all of those together so that you can aggregate away that metric dimension. Also for tail-based sampling, you want to collect a bunch of traces and then choose which traces to keep and which to drop. And you need a single collector to make that decision. Even cooler, you can take traces and make metrics out of them. But in order for the metrics to be complete, you need to make sure that you get all of those traces in the same place. And that leads us to the first architecture, which is just running a single collector. This is the way that most people will get started. And like I showed on the last slide, using this method can support global calculations. But as is probably obvious to most people watching, if you have too many applications and only one collector, that doesn't work very well. So the single collector can quickly become a scaling bottleneck. The logical progression from having a single collector is, well, let's have multiple collectors. So this is usually referred to as the collector service. This is horizontally scalable. You just put a bunch of collectors behind a single load balancer. And if you're using a push protocol, the application can send to a consistent load balancer IP, which is then load balanced across your horizontally scaled collectors. But unfortunately, now you aren't able to do those global calculations we talked about previously. For pull, things are a little bit trickier, but you can still achieve a horizontally scaled set of collectors. The problem you have now is that, number one, you need all the collectors to figure out which applications to scrape. And two, you need them to agree on which targets each one is going to scrape. So we call that sharding. And it turns out if you run too many collectors and you only have a single source for service discovery, there can be a bottleneck there as well. For example, in Kubernetes, if you're running the collector as a deployment and you're watching the Kubernetes API server as your source for service discovery, the API server can become overloaded if you scale your deployment up too high. And I separated the push and pull slides, but in reality, the same set of collectors can do both push and pull. It's just easier for me to explain in separate slides. Another way to set up collectors is to run one collector on each virtual machine instance you have. If you have a workload that's replicated the same way across multiple VMs, then this can be a really easy way to monitor them, since you don't need to think about, well, what happens if I add a new VM, since there's already a collector that's going to be on that new VM. It's also useful if you wanted to collect some telemetry from the host itself, like the CPU usage of the VM. But if your applications aren't spread out evenly, at least in terms of the telemetry they generate, this can be harder to manage. One additional problem that can bite you is that if you want your collectors to dynamically figure out which pull targets to scrape, this can easily overload your service discovery. In Kubernetes, for example, it's generally not a good idea to watch all services from a daemon set. So this sort of thing wouldn't fly there. The final architecture I want to cover is running the collector as a sidecar, which is generally referred to as the agent mode of the collector. This lets each application developer manage the configuration for their own telemetry pipeline to meet their needs. It also ensures that there aren't any central points of failure, since each collector is responsible only for telemetry from its own application. But it can be expensive running all those collectors, and it's hard to manage without proper tooling. To recap, I'd recommend getting started with a single collector and then branching out from there. The collector service is a good choice generally, but you'll likely want some metrics from hosts as well, so maybe some per VM collectors. But you don't have to stick with one approach. It's common, for example, to mix and match sidecars, which get telemetry offloaded quickly from the applications, and then forwarding that on to a collector service, which communicates with the backend. But broadly speaking, it's okay to mix and match and use the right tool for each job. If all of that sounds a bit intimidating and you're on Kubernetes, I have great news for you. The OpenTelemetry operator can make your life quite a bit easier. It lets you choose from all those deployment modes that we've talked about, like a daemon set, one on each VM, a sidecar, or a deployment. And it can also manage auto instrumentation, which is an easy way to get value from OpenTelemetry without making any code changes to your application. And with that, thank you so much for listening to us today. And I hope you have the best of luck applying all of this to your own environment.